The next question is from JEE 2000. What would be the major product in the following reaction? And the reaction is CH3, a carbon atom, CH3, CH3, CH2, Br, and the reactants are C2H5OH and heat. Again, we have our clue. Heat is given and it's a protic solvent. So there are two possibilities. Obviously, it's not a strong nucleophile or a strong base. So we cannot have SN2 or E2. Both these possibilities are eliminated. The only two possibilities are SN1 reaction or a even reaction. Okay, so both of these are two-step reactions. The first step is elimination of the leaving group. Thus, it forms a 1 degree carbocation. CH3, CH3, CH3. It's a 1 degree carbocation. And we know very well that 1 degree carbocation is not stable at all. So it will have a shift. The only option to shift is methyl because we don't have H in this case. So there will be a methyl shift. This is a classic example of a methyl shift. In unavailability of H group, a methyl group is being shifted. So the new molecule formed is CH3, CH3, CH2CH3, and there is a carbocation at this position. Now there can be two products. The first one is attack of C2H5OH as a nucleophile, thus giving our SN1 product, which is here it is CH2CH3, here it is CH3, here it is CH3, and here it is OC2H5. Okay, so this is our SN1 product. The even product can be by the elimination of either this H or this H. There will be two possible products. Let's say if this H is being eliminated, so we'll have this carbon. There are two attachments, CH2, CH3 and CH3 attached to this carbon, and a double bond formed is in between this carbon. So this is one possible product. The second possible product is if it snatches this hydrogen, which will be carbon, double bond carbon. Now this carbon has two methyl groups attached, CH3, CH3, and this carbon group has one H and one CH3 attached. That is, there will be one H, one CH3 attached. So this is the second possibility. So in the question, it was asked that what could be the products. So mainly there are three possible products. One was this, one was this, one was this. The next question is from JEE 2009. Sorry, JEE 1999. 199. The question is a solution of plus, it is the optical rotation, 2-chloro, 2-phenylethane, in toluene racemizes slowly in presence of a small amount of SbCl5. We have small amount of SbCl5. We have toluene as solvent, and this we have to draw the structure of 2-chloro 2-phenyl ethane. In ethane we have 2 carbons. Both chloro and phenyl groups are at position 2. That is chloro phenyl H CH3. Okay. So this is a chiral molecule, and what he is asking is, what if it racemizes? It is given in the question that it racemizes. Now as soon as this word comes, it is understood that we cannot have SN2 because SN2 is a stereospecific reaction, and if it racemizes, that it cannot undergo through SN2 mechanism, it has to undergo SN1 mechanism. Okay, so what actually happens is it leads to the formation of a carcation, which is CH3 phenyl. A carcation is formed. Now we have SbCl5 in our reaction mixture, which can provide Cl. So this Cl will attack as Cl minus and will be attached to this carcation, giving us both possible configurations. Let's say the initial one was R, but once a carcation is formed, it is a planar molecule. Now the attack can be happen both sides. It can be attack above the molecule or below the molecule, that is above the molecular plane or below the molecular plane. Thus the final product will give us both R and S. Thus it racemizes. So the presence of SbCl5 racemizes the mixture. Hence, now the 4 options which are given is due to the formation of A, anion, B is carbene, C is free radical, D is carcation. Now, no carbanion is formed, no carbene is formed, no free radical is formed, a carcation is formed. This is our intermediate carcation. Thus, the correct option is D. It is a very straightforward question. The only thing you have to do in this question is don't get confused by seeing such terms. Toluene is a solvent, SbCl5 is for racemization. Don't get confused by seeing these terms. It's a very straightforward question. It's just to test the patience of the students. Okay, the next question is from JEE 1999, and the question is the ether. We have an ether molecule which is a benzene ring, O CH2, again a benzene ring. The ether, when treated with HI, now HI is being treated, so it is H plus and I minus. So the first step is O will attack on vacant orbital of H, thus it will form OH plus. Now we have 2 options. The first one is this bond is being broken and the positive charge is being shifted on this carbon, or this bond is being broken and this positive charge is being shifted on this carbon. So let us consider both the choices. In the first case, this bond is being broken So what we are getting is OH plus, since this bond is broken, a carbocation on this. Now, this is a very stable carbocation because it is in conjugation with the electrons of benzene ring, and this is a phenol. In this case, if this bond is being broken, then we get a positive charge on a benzene ring carbon. See, it's a sp2 carbon. Hence, it is very electronegative, and positive charge on electronegative atom is not preferred. Okay, so this pathway will not be preferred. Hence, this is our final answer. The options were phenyl CH2I. Now, this is the first step, formation of a carbocation. Once a carbocation is formed, this I minus, which is present in the mixture, will come and attack, forming a phenyl CH2I. So, this option is correct. That is, A option is correct. It's a multiple choice question. The second option was phenyl CH2OH. No, this will be wrong. The C option was the phenyl CH2OH will be formed in this case, but since it's not possible, so this will not be our answer. The next one is C option is phenyl I. No, it will not be possible because this cannot be formed. The D option is phenyl OH. Yes, phenol. It is formed in this case. So A and D are our answer. The next question is from JEE 1998. The question is phenyl CH2 CHCl phenyl, and there is alcoholic KOH, and there is hue. Now KOH is a very strong base. Alcoholic KOH is a very strong base, and it is asking us to identify the final product. Since it's a strong base, we'll have to go through a E2 mechanism. If it was a weak base, then we could have gone through E1 mechanism, but since a strong base is given, we have to undergo a E2 reaction. Thus, this HCl will be eliminated from the molecule, forming a alkene, which will be phenyl CH double bond CH phenyl. This is our final product. So this is it. The next question is from JEE, again from JEE 1998. The question says, why acid catalyze dehydration of tertiary butanol? Note the important keywords. Tertiary butanol is faster than normal butanol, and it's a acid catalyzed dehydration. Now, in acid catalyzed dehydration, and the final product is a alkene. So basically, we have to convert this alcohol into alkene, and a tertiary butanol means OH, CH3, 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 whereas a normal butanol means there is a CH3, CH2, CH2, and then again there is a 4 carbon in the chain and OH at the 1 degree carbon. So if we do an acid catalyzed reaction, that is H plus, this O lone base will attack on the vacant orbital of H plus forming OH2 plus, and it will act as a leaving group. The carb cation will come at this carbon. So the carb cation formed is 3 degree carb cation. Whereas in this case, the carb cation formed is a 1 degree carb cation, which can at maximum after shift can become a 2 degree carb cation. So obviously this one will be preferred, since a 3 degree carb cation is much more stable than a 1 degree or a 2 degree carb cation. Hence the acid catalyzation of 2 degree tertiary butanol is faster than normal butanol. This is what we have to explain in this question.